Hello everyone, welcome to a new video. So in today's video, we will be discussing a new problem. So the problem of the day is sequence of sequence. Let's see the problem statement given. Given two integers m and n, try making a special sequence of numbers, sequence of length n, such that then we are given with three conditions, that is sequence of I plus 1 should be greater than 2 into sequence of I. The sequence of I should be greater than 0. That means none of the elements in a sequence should be negative. And the last condition is sequence of I is less than equals to m. So m is the given integer in our question, and our elements of the sequence should be lesser or equals to that integer. And our task is to determine total number of such special sequences possible. So let's see the first example given in the problem to get more clarity, and then we will see how to approach this problem. So our first example is m equals to 10 and n is equals to 4. This is the given conditions we have to follow to make a sequence. So now let's understand the question, or what we have to do in this problem. So given the value of n is 4, thus we have to create a sequence of length 4. Then it is stated the value of m is 10. So our max value is 10, and every element in our sequence should be lesser or equals to this value. Every elements. So let's say I is the elements in our sequence. So I must be lesser or equals to 10 according to this question. So now we will create a sequence, a special sequence, and according to the second condition, the sequence should be greater than 0. So let's say our first element is 1. We can take 1 because it is greater than 0. Now to continue with our sequence, we have to follow the first condition as well. That is, the next element should be greater than or equals to 2 into the present element, that is 1. So if we multiply it with 2, we will get 2. So this element can be 2 or more than 2. That is, we can take 3, 4, till m we can take any. But the catch is we have to fill this sequence with n elements. So at first we will fill all the values by multiplying all the elements with 2. So in the first case we have multiplied 1 with 2, we got 2, and the next element would be 2 into 2, which is 4, and 4 is less than 10, so we can add it easily. And in the next case again, if we multiply 4 with 2, we will get 8, and 8 is also less than the maximum value, which is 10, so we can add. So this is our first sequence we have created. Now what else we can create? If you see the third condition, the element can be less than equals to m. That means our last element can be 9 also over here because it is less than or equals to 10. So to achieve this element, in the previous element, that is 4, we have multiplied it with 2 and then added with 1. So we have achieved this 9. And the rest of the sequence will be same, because if we have multiplied 1 with 2, we got 2, then 2 into 2 we got 4, and then we have multiplied 2 with 4 and added it by 1, so we got 9. And this is also a possible special sequence. Now let's check whether we can create any more special sequence or not. Again, we can see the last element is 9, which is less than or equals to 10. So we can take 10 as our last elements also. In this case, to the previous element 4, we have multiplied 4 with 2 and then added 2 to it. Hence we got 10. And this is a valid sequence, if you can see, as it is following all the three conditions. The elements are less than or equals to the max value, the length is also 4, and all the elements are positive. Now check, is there any other special sequence? Now check, is there any other special sequence possible? I can see one. If we divide 10 by 2, we got 5. And according to the given condition, the previous element should be lesser than or equals to the double of the present element. Thus, we can take 5 here. So the new sequence will be 1, 2, 5, and 10. And if you check that 5 into 2 is 10, so we are not violating any condition because we are multiplying it with 2 and creating a new element. And if you check this element also, we are multiplying 2 with 2 and then adding 1 to it, so we are getting 5, and thus we are not violating any conditions and we are creating a new sequence. So are we left with any of the subsequence? Let's check. If we divide 5 with 2, we got 2, so we can't increase it. We can't increase the previous element, because if we increase it with 3, then the next element should be 6, like this. The next element should be at least 6, that is 3 into 2, that is 6, and the last element should be 6 into 2, that is 12, which is not possible, right? Because our maximum value is 10, how we can add 12? So this is not a possible special sequence, so we will not include it, and thus we are here with 4 special sequences, so our output is 4. So by now we are clear with the problem and what we have to do in this problem. So let's discuss the approach to this problem as well. So we will take the same example, that is m, the maximum value is 10, and n, the given length of the sequence which we have to create is 4. We will create a dynamic table of length m plus 1 and n plus 1. And in this table, we will store the maximum possible sequences, special sequences we can create for the given value of m and n. So in this table, our row will indicate the maximum values and the columns will indicate the length of the sequences. So let's create the table of m plus 1 rows and n plus 1 columns. So n in our first example was 4. So we will create 5 columns. And the value of m was 10. So we will create 10 rows. So we have created a dynamic table. Now it will store the maximum possible sequences of a particular max value of length j. So our column is indicating the length of the special sequences. So this is our zeroth index, this is first index, this is two index, this is third, and this is the last index. So these indexes actually indicates the maximum length possible. That means in this column, in zeroth column, we will store all the possible ways to create a special sequence of length 0, and in the first column we will store all the possible ways to create a sequence of length 1, and accordingly we will fill all the columns. And in the row we are storing the max value, that means the maximum value of a sequence can store. We have discussed it in the example, right? In this example the maximum value is 10. So in this table we will calculate the possible sequences for all the max values. So now I hope you are clear that we are using dynamic programming approach to solve this problem. So we need some base cases to fill the dynamic table, and our base cases are if the value of I and j is equals to 0. That means with a max value of 0 and the length of the sequence, special sequence is 0. Can we create any such sequence? We can't create, right? We can't create a sequence with length 0. We need some minimum length to create a sequence, and thus for every such condition we will put 0 in our table. Our next base case is when our I, which is the max value, is less than j, which is the length of the string. So if our max value itself is less than the length of the sequence, how we will create that sequence? For example, if the max value given is 1 and we have to create a sequence of length 2, is it possible? Is it ever possible? It is not possible, right? Because the max value is 1. So if we add 1 in the first index of the sequence, how we will fill our next index? So this is not possible ever. So in this case also we will put 0 in our table. And our next base case will be if the length of the sequence which we have to create is 1, thus j equals to 1. This means at most we can create I number of special sequences. Let me show how. In this case, when j is equals to 1, that means the length means n is given as 1, and our m can be anything like 5, 10, anything. So how many possible sequences, special sequences we can have? At first we can make a sequence as 1, second sequence will containing 2, third sequence will contain 3. Like this we can make 5 such sequences. So these are all the possible sequences, special sequences of length 1, and the max value is 5. Thus we have created 5 sequences. So we can see the possible number of special sequences is equal to the max value itself. Thus we will return I in this case. In our DP table we will just return I. So I indicates the max value and j indicates the length of the subsequence. Now we will start filling all the values in our DP table following these conditions, these base cases. So let's start in the index 0, 0. This indicates the max value is 0, and we have to create a sequence which has length 0, which is never possible, which we have discussed in our first base condition, that is I equals to 0 and j is equals to 0. So we will put 0 in this case in our table. Now what this index is indicating? This is indicating we have the max value 0 and the length of the special sequence is 1. So how many special sequence we can create with the max value 0 and whose length will be 1? Can we create any such sequences? No, it is not possible, right? Our max value is itself less than the length of the sequence which we have to create. So we have discussed in the base case, the second base case, that is I is less than j, then we will add 0 in our table. Thus we will put 0 in every indexes of our table. Now we can see our max value is 1 and the length is 0. So we can't create a sequence of length 0. It is never possible to create a sequence of length 0. Is it possible? No, right? So we will simply add 0 in each of these cases. So all the values in the first column will be 0. I hope you understand the logic behind this. Now let's see the case where our max value is 1 and the length is 1. So we can create a sequence of length 1 with max value 1, that is 1. 1 itself. We can create, right? So the value will be 1. This is the only possible way, thus we have added 1. And now the second, in the next index, we have max value 1 and the length is 2. Is it possible? We can't create any sequence of length which is greater than the given max value. Thus, for every index, we will put 0 in the table. So in the next iteration, we can see our max value is 2 and we have to calculate the number of possible ways we can create a sequence of length 1. So as we have discussed the base condition, when the j value is 1, that is the length is 1, we have to return the max value itself. And the reason I have discussed already here. So for all the indexes where j is equals to 1, we can simply add the value, the max value itself. Now see this index where the max value is 2 and the length of the sequence we have to create is 2. That means this is the length, means the sequence contains 2 elements and the max value is 2. So the value can be 1 and 2 into 1, that is 2. This is only possible over here. Can you create any other sequence by this value? No, right? Thus, the number of possible way to create such sequence is 1 and we will add 1 in this table. And the next values will be 0 because here the j value, that is the length of the sequence, is greater than the max value. Thus, we will simply put 0. In the next iteration also, when the max value is 3, we can insert 0 in this index because 4 is greater than 3. And now we have to calculate the possible number of ways to create a sequence of max value 3 and the length of 2. So let's see how many possible ways are there. So if we have length 2, that means we will add 2 elements. In the first index, if we add 1 and the next index will be 2 times greater than previous, so it will be 2. This is a possible sequence, and the other sequence can be the first element is 1 and the next element will be 2 into 1 plus 1, that is 3. So these are the two possible sequences which we can create with the max value 3 and the length of the sequence is 2. Thus, in the table we will add 2 in this position. Now let's count for length 3. That means the sequence will contain 3 elements and the max value is 3. So if we add 1 in the first index, then the next index will be 2 times greater, which is 2. And the next element should be 4. 2 times greater of 2 is 4, but the max value in this case is 3. Thus this is not a valid sequence and we can't insert this. And if you notice, none of the combination will satisfy this condition. Thus we have to insert 0 in this place. That means there is no possible ways to create such sequence. So now if you see, our max value is going on increasing and the length is also increasing as well. So it is becoming impossible to calculate possible number of sequences and add it to our table. So for that we need a formula, and the formula to calculate the total number of sequences which we can create is dp of I minus 1, that is the previous max value, and we will add dp of I by 2, that is if we divide the current max value. Was there any possible way to create such sequences? So based on this value we will keep on updating our table. So I hope this is clear. We are simply adding the number of possible ways which we have counted for the previous max value of the previous possible ways when the max value is divided by 2. We have done this thing, right? We have calculated if the current max value is divided by 2, is it possible to create such sequence of a smaller length, that is till here? Is it possible to create? Yes, it was possible, and thus it was considered as a possible way to create a special sequence. And the same logic we are using in this formula, and if we calculate the value for this index, that is 4 comma 2, according to the formula we will go to 3 comma 2 of our dp table, add that value to I by 2, that is 2 comma j minus 1, which is 1. We have to add these values from our dp table. So 3 comma 2 is 2 and 2 comma 1 is also 2, so the value will be 4. That means there are 4 possible ways to create such sequence, such special sequence of max value 4 and whose length will be 2. and accordingly we will fill the rest of the indexes in our table. So for 4 comma 3 it will be 1 and 0. So by now I hope I am able to make you clear that how to fill the values in our dp table and how we will calculate the possible number of ways to create a special sequence. So let's quickly fill the table and then see our outcome. So after filling all the values in the last index, we got our final result, that is 4. Because we have to calculate, because in our question it was given the max value is 10 and the length of the sequence is 4. So we have stored that value. So our answer will be stored in dp of 10 comma 4, that is this index, the last index of the matrix. Thus we have got 4 as our final result, which is our expected output. We can see we have calculated these 4 set of special sequence which we can create. So this was the use of our dynamic table. I hope I have made this problem simpler to you. And if we talk about the time complexity of the program, we have to iterate each and every indexes of our dynamic table, that is a 2D array. So the time complexity will be big O of m into n, where m is the number of rows and n is the number of column. And similarly, the space complexity will be also big O of m into n, because we have to store all the values in this matrix whose size is m cross n. Thus, if you want to solve this problem in the expected time and space complexity, that was the expected space complexity was big O of 1. In this case, you have to use recursion, but we are solving this problem using dynamic programming approach. So now let's get into the code. So as we have discussed, we will create a dynamic table. So int dp equals to new int, and the size will be m plus 1 and n plus 1. Now we will iterate through every index of our matrix and add the values accordingly. So it will start from 0 and iterate till the length of our row and will increase by 1. Similarly, our j will iterate from 0 till the length of column, and j will increase by 1 as well. Now we will quickly write the base cases, that is if the max value and the length of the sequence is 0, in that case we will simply add 0 in our dynamic table for dp of I comma j equals to 0. The second base case was if the value of I is less than j, we can't create such sequences. Thus in this case also we will add 0 in our dp table. And the last base case was if the value of j, that is the length, is equals to 1. In this case the possible ways to create the such sequence is the max value itself, that is I. So we will add I. And else if none of the condition satisfies, that means we have to calculate using the formula which we have seen for I and jth index, that is dp of I minus 1 and j plus dp of I by 2 comma j minus 1. So our result will be stored at the last index of the dp table. So we will return dp of mn. Thus we have completed our code. Now let's quickly compile our code. So it is compiling fine. Let's submit our code. Yeah, so our code has compiled successfully and passed all the given test cases. The total time taken is 0.23. If you have done this program using recursion technique, let me know your total time taken in the comment section. So that was all about this video. I just wanted to solve this problem using a different technique rather than using the recursion. I have used dynamic programming. Hope this video was informative. And if you have learned anything new from this video, please don't forget to like, share and subscribe my channel. And let's get back with a new problem tomorrow. Till then, happy coding.